All right, let's go over the quiz here. So, the first one, the geologist studies two rock outcrops from different locations. Some of the strata contain index fossils, which are shown in the image below. All right, so I guess whatever you see here, consider it an index fossil, meaning that it is widespread geographically and it only existed for a specific period of time. So, or you could just say, hey, what's my general rule when it comes to relative ages of rocks? Well, the one on the bottom is the oldest. So it's either C that's the oldest, or it's F that's the oldest. But since you can see C and D appear to contain the same index fossil, you can kind of line them up. So if I take this whole column and I shift it down so that this ammonite fossil is aligned with this ammonite fossil, then it's pretty easy to see that all this stuff, E and F, are older than any of this stuff, meaning that F is the oldest layer. All right, so that's the correct answer, F. Next one, geologist studies two rock outcrops, and now we want to do which one's the youngest. So you use the same concept. Again, it's either going to be A or D, but since C and D appear to match the same texture, the same fossil, all that stuff, I think it's safe to align those two and then call A the youngest layer. Now, which are approximately the same age? Well, we probably should have started with this one, to be honest, because this concept is crucial if you want to identify the youngest layer. So again, C and D, they have the same fossil, they have the same little texture and whatnot, so they're the same. Then this one, got a few questions on this. So again, what is an index fossil? Well, it is something that was widespread geographically and that existed for a specific period of geologic time. So what is the thing here that best fits those two criteria? Well, let's take a look at this thing that almost looks like a butterfly. But it is all over the place, right? It's down in this layer and it goes in the intermediate layer, and then it's at the youngest layer too. So that's not a very good index fossil because it spans a bunch of time. It was around for this entire period of time, so not so good. Trilobite, which is this little guy, same thing. It goes through all four different layers, so that is not a very good index fossil. What about this little spring-looking thing here? Well, it was around for only one period of time, which is this kind of brick-looking layer. But it's not widespread, right? It was just an outcrop for, it didn't show up here, didn't show up here, didn't show up here. So I think you can see process of elimination that we're looking at this ammonite fossil because it's widespread. It's in every single one of these layers, right? And it was only in one, it only was around for one specific period of geologic time. So it only showed up in this layer. It's not in any of the rocks that are older or younger. So what a great index fossil it is. And it's true, ammonites are an index fossil. Down here, so we have this Scaphitis hippocrepus, which is this thing. And you find this rock this fossil in a rock near your house. Knowing that this organism is an index fossil, you conclude that the rock must be from it's got to be from the Cretaceous, which is in the Mesozoic. So technically both of these things are true. It is from both the Cretaceous and the Mesozoic. So I have boom, from the Cretaceous, from the Mesozoic era. Now I got a question on this one that said, hey, Mr. Hall, shouldn't it just be the Cretaceous? Because the whole concept of an index fossil is that it's helping us to, find the age specifically, or as close as possible, find the age of a rock. And that's a fair point. So if we were doing this, I could go back. Yeah, I'll go back and I'd change the key so that if you just clicked Cretaceous and not both Mesozoic and Cretaceous, then you got the correct answer. Because I understand what you're saying. You're saying that this is more specific, and so that's better information than just saying, oh yeah, it's in the Mesozoic. Because if it's in the Mesozoic, you could get any of these fossils. So fair play. I think either answer is great, and we're going to move on. Okay, so what is the best explanation for why there are no fossils or index fossils in the Precambrian? So Precambrian is nearly 4 billion years of geologic time. A really long time. Now, we know there was life because, well, this stuff couldn't just show up all at once in the Cambrian. So that's no good. Life before the Cambrian wasn't fossilized because Earth's environment was too harsh. Well, that was probably true in the very first, like the Hadean eon. That was probably true then. But as this is 4 billion years of time. So at some point, there must have come along some conditions that were moderately hospitable, that somehow magically something would have been preserved, which is in fact the case. There's not an abundance of fossils from back then, but there definitely are. It's not as if there's a massive absence from the Precambrian. So it was more that the life was too small and squishy. So I believe that was covered in that slideshow. And so that's the best answer. Precambrian didn't last long enough. Yeah, that's a joke question because it was a super long period of time. All right. Next question. Studying the geologic timescale below, what patterns do you notice? Well, notice how things become more detailed and the divisions of time become smaller. Now, the Phanerozoic looks like it's a really long period of time because it's a really tall box, right? But if you pay attention to the numbers, this is 541 million years, and the Proterozoic was, let's do some math here, more than 2 billion years longer. So this is actually like a quarter, roughly, of the time that the Proterozoic was, but its box is just massive. So the box size doesn't actually correlate to the time that was covered. It more correlates to the amount of detail that we have about that particular eon. So, the correct answer. The length of the eras gets shorter as you get closer to present day, right? So here's the eras. They are getting shorter. The Cenozoic is 66. The Mesozoic is less than 200. And then this one's definitely over 200, more like 300. So the time spans become smaller as you get closer to present day. And then the number of divisions become greater as you get closer to present day. Yeah. Do you know why that is? We have more rocks we have more newer rocks. The newer the rock is, the more likely it is it's still around. If it's old, it gets destroyed by wind, weather, etc., and it goes bye-bye. Which division of geologic time do we live in currently? Hey, any of these things. The Holocene, the Quaternary, the Cenozoic, the Phanerozoic. Because this word division isn't specific. It's just saying, hey, we're in geologic time somewhere. So depending on if somebody asks you what eon, era, period, epoch you were in, you would say a different thing. So all of the above was the correct answer there. Oh, yes. Right. This is a fun little concept that we have created ourselves a new geologic time division that we need to add to the geologic time scale. And that would be plopped in right here in the epochs. And that would be called the Anthropocene. So we're definitely making a heck of an impact on the planet. And if we hang out long enough, or even if we don't, like even if we die, humanity becomes extinct, then some other critter maybe would evolve and become intelligent and start looking at the rocks and doing the same thing we did, which is piece together the whole story of geologic time, and they'd be like, whoa, look at this crazy layer, and it would be very apparent that something new had taken place during that time, geologically speaking. I mean, I'm saying this new critters comes along 1 billion years after we're gone. It would be very easy to spot that some massive changes had occurred on the planet. And that's not just ruins of humans and whatnot. That's just the rocks. It's everything in the rocks. So what would you see? Well, you'd see a decrease in diversity of preserved organisms. You'd see sudden and widespread appearance of plastics. And you'd see the sudden appearance of radioactive isotopes. Now, this is not really a fair question, but it's because we didn't cover any of this stuff. But I just thought it was interesting, and many of you got it right. And since this is not going to go in the grade book as a particular letter grade, it was more me just wanting to shove that information in there for fun. What are the major themes of geologic time? Well, Life on Earth is stable for a while, and then some event comes along, kills a bunch of critters, and then new stuff evolves to take its place, right? That's kind of the short synopsis of what has happened repeatedly over the course of geologic time. Choose the correct statement above, or the correct statement. Evolution is completely random. Evolution is a result of environmental changes. Well, there's a little bit of randomness in evolution, but it doesn't just happen. You don't just get critters that are randomly evolved. They are evolved to meet the environmental challenges or changes that nature throws at them. And then lastly, choose the correct statement. Individual organisms evolve in a single lifespan. No, it takes longer than a single lifespan. And generally, the evolution is being done at the population level rather than at the individual level. Great. I hope you did well. And I'm going to change the key. So if you had one of those questions, like I believe it was this one, then you will have gotten another point. So, great job.